Hi, just having a look at some of the questions that you asked me about. Looking at 5e first, we've got this equation, y equals a log e of x minus b plus c. They've told us these three bits of information. It goes through the point 3, 10, 5, 12, and it also has the x asymptote at x equals 1. So that one is probably the most straightforward part, x equals 1. It just means that this bit up here must be x minus 1. Okay, because that will mean that the asymptote has been moved to the right one, so therefore we can say that b actually equals 1 in this case. So that's probably the easiest thing to do. You probably don't, you don't need to prove anything, you just need to put that in. The other thing that I'm now going to do is substitute these 2 points in and get two equations, and I'll have two unknowns, the a and the c, and I'll solve them simultaneously. It's a little bit tricky solving simultaneous equations with logs and exponentials, but it can be done, and I'll show you how that might work. So we substitute that in and you get 10 equals a log e2 plus c, and you get 12 equals a log e4 plus c. Now to solve these two simultaneously, if I subtract one equation from the other, this c will be cancelled out, okay, because it'll be plus c and then minus c. And whenever you subtract, I guess you'll get 10 minus 12 or 12 minus 10, whichever way you decide to do it, and you'll get this thing here, a log e2 minus a log e4, or the other way around, a log e4 minus a log e2. And whenever you've got one log subtracted from another log, you simply divide the numbers inside the log. So that's how I'd go about this question, and then eventually you'd get the answer for what a is, and then find out a, and then you can find c. I think I've attached these solutions to the email, so I won't go through all that. I'll kind of let you have a go from there, but yeah, we can have a look at the solutions if you. For the questions in 5F, starting with 3C, it's very similar to one of the questions we did just the other day. The only difference is that it looks a little bit different. So I've got here 3 to the power of 2x minus 3 to the power of x plus 2 plus 8 equals 0. And again, I look at this and I think to myself, it's actually going to turn into a quadratic, something along the lines of, a squared minus, like I'll just make up a number, like 11a plus 8 or something like that. It's going to look very similar to that. This 3 to the power of x plus 2, as you can probably see from what I've done here, whenever you add the powers up here, that means what you've done previously is you've multiplied the two bases. So I'm going to actually go in the reverse. I'm going to say 3 to the power of x times 3 to the power of 2, that's the same thing. And 3 to the power of 2 is actually, that actually ends up being 9. So what I can then do is I can say 3 to the power of 2x minus 9 times 3 to the power of x plus 8 equals 0. And then I'm just going to say that let 3 to the power of x equal a. And then I've got this, a squared minus 9a plus 8 equals 0. And then I'd go, from there, I'd use the cross method or whatever method you want to use to find out what a is. And then I'd substitute this back up in and find out the values of x. So again, I'll let you kind of do that. The tricky bit from here is probably going from that point there to that point there. But I know that eventually it's going to look something like, what I had up here, the quadratics. Okay. Now, this question 7 is actually quite a tricky question. It relies on a rule that we don't often use anymore because our calculators are quite good now, but the rule still does apply. So I'll explore that. There's probably a variety of ways that you could actually do this question, but this is the way that I've discovered, that I think works for me. So the rule is this one. Imagine if I had log 5 3. Now, at the moment, like if you were asked to do, find the answer to this question, a decimal approximation, you'd probably just go straight to your calculator and type in log 5 of 3. But back in the day, they didn't have the calculator function that did this, so we actually had to introduce another a variable into this. Or on the old calculators, we were only able to do log to the base 10 or log to the base e. Because it had those buttons but no other buttons, and now the calculator is a lot better. So what we used to do in this situation is we used to make that log to the base 10 of 3 over log to the base 10 of 5. And that will give us the same answer. I mean, you can try that yourself if you want to, but this will give us the exact same answer. And so I guess this is the rule that we use, and I guess we can generalize a little bit if you want to. So, I mean, if it was log a of b, you can make that log c of b over log C of A, or something like that. I mean, that's the generalized rule that we use. And what we're going to do is we're going to use that idea, that generalized rule, for each of these components here. Now, so essentially what you can do is you can introduce any new variable in here, as long as you do it consistently. So, you know, this can be another number or another letter, whatever, C, as long as that one there is B and that one there is A. That's the rule that I'm going to use. And what I'm going to do is I'm actually going to turn this into the proof that they wanted me to do. Very, very tricky question. I can look from the answer. They want me to get 1 over log A of B, I think is the first part, you know, adding all the other things there. And I can look at this one, and I can see that, you know, the top bit needs to be 1 and the bottom bit needs to be log A of B. And so I can see that that's log A down the bottom there. So what I'm going to do is I'm actually going to get this bit here, log B of A. I'm actually going to make it log A of A over log A of B. So this new number that I'm going to introduce, or this new variable, is I'm actually going to introduce A as the variable. So make it log A of A over log A of B, because that will get me the log A of B on the bottom, and then the log A of A is just 1 anyway. So that's what I can do in order to turn this part here into this part here. I just take log A of A and log B of B. And I'm going to do a very similar thing for this one here, because what I wanted on the bottom here is I wanted log B of C. And so if I want to do the same thing here, I can do that easily. I can say that log C of B is actually equal to log B of B, because, you know, B is the letter I've introduced, over log B of C. And again, this log B of B will cancel out to give me 1, and I'll end up with log B of C on the bottom. And then finally, I've got this other rule over here, this one over here, and I want that to turn into log 1 over log C of A. And so again, this C of A, C is the base, and so A is the part here. So what I can do for that is I can say log A of C actually equals log C of C over log C of A, and that turns into 1. So it's this question, you know, quite challenging. It took me a while to actually think it through, but I realized I had to muck around with this rule here. And this rule relies on us being able to introduce a third variable in order to manipulate or do whatever we like to it. So there are probably other ways to go about this question, but that's probably how I would tackle it. I do actually remember this being very similar to an exam question a couple of years ago. I think I've found the exam. It was 2011, question 22. So there, you know, if you would like to have a go at that question by yourself, I guess you could. It was not very well done in the exam. In fact, I think only 45% of people got this question correctly. Way back then in 2011, and they had their calculator too, so it was probably even a little bit easier with a calculator. But you could have a go at that question if you'd like to, and yeah, let me know if you'd like any more help with that. Moving on to question 8, we're given these two things: log R of P equals Q, and log Q of R equals P, and we have to somehow combine these two things to show that log Q of P equals PQ. So I really didn't know what to do with this. I just started to muck around with it just to see. A lot of these show that questions, really you kind of find the answer just kind of by mucking around or just, you know, playing around with these things because there's, you know, probably, you know, there's some shorter ways of doing things, but there's not necessarily a right way. So what I did here was what I was trying to explain to you the other day. I can change this into this format using a couple of different methods. I guess you can just remember that, you know, which bit goes where, or the other way that you could go about this is to raise both sides to the power of r, and r to the power of log r will always cancel itself out and just be equal to whatever that was there. So in this case it's p, and then so you do r to the power of q on this side as well. So either way, in any case, as long as you can get to this bit, that's okay. And then once I did that, I thought, well, that can turn into something like r equals the qth root, whatever the heck that means, of p. And once I got it in that format, I thought, well, now I can substitute this bit up into this part here, and it's going to start to be a little bit nicer for me. So again, I'd probably actually no. What I'll do is I'll leave it there, and then you can have a go from that point onwards. See how you go. But I've also attached the solutions to the email as well, so you could have a look at the solutions. So question 9, it's just a matter of sort of rearranging and transposing. U equals log 9 of x, and I wanted to find out what x equals in terms of u, so that means I'll just have x equals something u, or 9a was that anyway. So what I'm going to do is I'm going to try and get x by itself, and again I could either just rearrange it simply by knowing which bit goes where, or to get rid of the log, I raise both sides to the power of whatever the log is. So if I raise this side to the power of 9 and this side to the power of 9, I'm going to get 9 log 9, which will cancel out to just be whatever the thing is there, which is x, and that will be 9 to the power of u. Okay, and that's the answer for A. For B, it's fairly similar. I needed to recognize that log 9 of 3x actually turns into log 9 of 3 plus log 9 of x. And I already know, and then I had to get rid of x essentially and make it in terms of u. I already knew what log 9 of x was because I've done that previously. Actually, I've done more work than I need to. Log 9 of x is simply u, so I could have just written u. I've done a little bit of extra work and still found out that it equals u anyway, but I didn't need to. So that's recognizing that log 9 of 3x can be split up into log 9 of 3 plus log 9 of x. Usually we condense those two to get to that, but in this case we've done the opposite way around. For question C, I'm going to do some fancy stuff. I've got log x of 81, and I'm going to turn that 81 into a 9 because the previous parts of the question have all been dealing with 9, so I'm going to somehow get that down to that. So 81 is just 9 squared, and then once I've got that 9 to the power of 2, then I can drag the power of 2 out the front, and I've got 2 log x 9. Now that's similar but a little bit different to what I had in my first part of the question. The first part of the question was u equals log 9 of x, and in this case I've actually got log x of 9, and we wonder, how do we change and mix around these sorts of things. It sort of relies on that rule that I was talking to you about before, that says you can actually introduce a third variable if you want to, or even any variable or any number as a log. So I want to turn this log to the base x, I want to turn that into log to the base 9. So what I'm going to do is I'm actually going to transform this a little bit. I'm going to say that is the same as log to the base 9 of 9 over log to the base 9 of x, because in this case I'm actually going to get that there. Log to the base 9 of 9 is just 1 anyway, and then this bit here is just u, and then I can sort of go from there. Hopefully that helps you out in that situation there. If you need some more help with that kind of stuff, just let me know. And I think the last question I had a look at was question 11. Q to the power of p equals 25, and they asked us what log 5 of q is, I believe, in terms of p. And so what I'm going to do is I'm going to get log 5 of both sides, okay, because that's essentially what the question was asking me, what's log 5 of q, and so I'm going to get there eventually. I get log 5 of both sides, and I get log 5 of q to the power of p equals log 5 of 25. And then I'm going to do a bit of fancy rearranging on this one. I'll probably leave it there, but then if you want to have a look at the solutions as well, you can have a look at that. So hopefully that's helped you out with some of the questions that you had. If you've got any more questions, just let me know. Thanks.